Right, just the parts of a simple circuit. So a circuit, the name circuit means a closed loop. It comes from the word circle, right? So you have to make sure that you have a closed loop. Now, the parts of a circuit that all things have to have is that you have to have a charge pump, something that allows the charges to flow. So think about the steepness of a slope. The steeper the slope, the faster the charges will flow. And an example of a charge pump would be something like a battery or plugging your device into an electrical socket. The symbol in a circuit looks like two parallel lines, but they're uneven. It can just be one pair or it can be multiple pairs, but they always come in pairs. It's always a short line and a long line. The short line stands for the negative terminal, and the long line stands for the positive terminal. And you always have them in alternating short and long or negative and positive. You never have two positive ends next to each other, otherwise charges don't flow. You need a wire, which is like the track or the channel for the charges to flow. And an example that we have of that is a wire or the physical cord that you plug into the socket. The symbol in a circuit is just a straight line. And the final thing you need is a resistor. So a resistor converts the electrical energy that's coming in into the form of heat and or useful work. So examples of that are like a light bulb, a stove, a motor, basically anything that requires electricity. The symbol in a circuit is a zigzag line, and it doesn't really matter how many zigzags you have, it's just a zigzag line. And the units are ohms. We'll go over the actual units later. Sometimes you'll need a switch that allows you to control it as an on or off, right? So an example is like a start button to something or a light switch. And the symbol is an open diagonal line over a parallel line, almost as if you brought it back down, you would close the circuit. So you'll often see a switch in there or other devices, but really the only things you absolutely need are the power source, the battery, the wire, and the resistor. And however many of them isn't important just as long as you have one of each. So let's talk about what these parts are. So voltage measures how much push a charge is given. So it's kind of like a drop of water, right? So I can have the drop of water, it has the same mass, but how much push it gives, like if I'm feeling it on my hand, if it's coming just from the end of the water of the sink, right, a drop of water versus comes down all the way from the roof, it's going to hit my hand with a different force, right? So even though this isn't force in terms of Newton's worth of force, it has that same type of oomph, right? So the units that I have are called volts, and we use the symbol V in the equation. Current measures how quickly the charges flow through. So it's different than the voltage, right? I can have a drop coming down one at a time very slowly, and the power of that, the feeling of how it hits my hand, will be the voltage. How many of them hit my hand will be my current, right? So the current measures how quickly the charges flow through. And we actually measure it. So rather than following one charge all the way through and seeing that as my velocity, I'm really just basically taking, it's kind of like somebody standing by and watching and counting on a counter how many people pass by. That's how we measure current. So I'm measuring it by how many charges pass by in a second. The units of that are amperes or amps, and the capital A is what we use for the units. The symbol in the equation is I. And then resistance. So resistance measures how much of that electrical energy, right, that was given the voltage, gets converted to heat and or work. The units of that are ohms, and it's this omega, capital omega, as your units, your symbols. And the symbol in the equation is R, right? So remember that the symbol in the equation isn't always the same thing as the symbol of its unit. For example, force in an equation has a capital F, but the units are newtons, capital N. So how does this show? I have my voltage source here, I have my wire, I have a resistor, and the wire connects it all back, and this is my current. And the convention is that the current flows from the positive end to the negative end, or the long end to the short end.